You may not realize at this point, but we have learned lots of different ways to solve quadratics. Remind me, what are quadratics? What's a quadratic equation? Yeah, you equal it to 0. What classifies it as quadratic, though? How do we know it's quadratic? It's got something special about it. Close, it's the squared, right? It looks like this. And you're right, we always make it equal 0, even if it doesn't equal 0 to start with. And so we've spent a lot of time talking about ways that we can solve this kind of equation for x. Can you remember one way that we've done that? Okay, so you're telling me the way to do that, but what's that method called? What are you doing? Factoring, that's exactly right. One of the things we did was we factor and solve, meaning we multiply, like Ricky said, we multiply the A and the C together. We see what multiplies to that but adds to B, and then we slashed it, remember? And then everybody goes to 0 at the end. We also talked about another way. What other way did we talk about? I can't give the test back. I can give you your reviews and stuff back. What else did we do? We did one other way. It was the last test you took. It was the graphing. It was the graphing. We graphed, and then the solutions, or when we solved, was where it crossed the x-axis. So the x-intercepts were the answer. Okay. So the question becomes, what if none of those methods work well? What if there's nothing that it can't factor? What if there's nothing that multiplies to A and C but adds to B? And then who's missing today? And what if it's not an easy graph? I graph it and it crosses at some funky places and it's hard for me to do. What then can I do? And so the answer to that is we can use here's what we do. There's a formula, and it's kind of convoluted, and it's long, and we don't use it unless we have to because there's so many rooms to make mistakes, or so much room to make mistakes. But we use the A, the B, and the C, and we plug in this formula. So here's what it looks like. Y'all ready? Have y'all heard of the quadratic formula before? Opposite B. Now, I know I put negative B, but just like when we were doing the, good job, Shaisha. The vertex, whenever we were graphing and it was not negative B, it was opposite B, but there was a negative front. Same thing. All right, opposite B plus or minus the square root of B squared minus 4AC all over 2A. Now, a couple of cautions with this. Make sure your radical extends, meaning the square root, extends out far enough to cover the 4 and the A and the C also. And make sure that your entire fraction, where the 2A is, that everything goes under 2A. Okay? So, to be successful when you use this formula, there's an order that you have to do this in. And I always tell everybody, do what's under the radical first. Okay? After you simplify what's under the radical, and if it's a perfect root, then you can do that. The next thing you do is the whole top of the fraction. And then the last thing you do is you divide by 2A. So you want to make sure you go in the right order as you move through this big formula, okay? And yes, I will give you the formula. It's a pretty long formula. Did they give it to you yesterday? Did they give you the formula on the EOC practice yesterday? Pretty sure they give that to you on the... I'll check on that because we'll see. Oh, by the way, I forgot to tell y'all. Of warnings before you use the quadratic formula. Of course, watch the order that you solve in. The other thing is, before you use quadratic formula, your original formula must always equal 0 to start with. If it doesn't, You have to make it. Okay? And just like when we were graphing and we were doing the vertex and everything else, remember how we listed A equals this, B equals this, C equals that? We're going to do the same thing here, and then all we're going to do is literally plug in, plug and chug. Are you ready? Mm-hmm. Okay. Yes. We're going to do the same thing. We're going to list the A, the B, and the C. Minus 8, because anytime I use quadratic formula, it has to equal 0, and this doesn't. So, Christian, you're right. I need to minus 8. We're doing the same thing. We're getting to the same answers. We're just doing it a different way. It won't, there's nothing that multiplies to negative 24 but adds to 5. So it won't work. Actually, there is. This one will, but always.
Yeah, it is, because what's
8, negative 3. It will, but I want to show you with quadratic formula. They all won't do that. All right, here we go. What is A?
3.
B? And C? Negative 8, okay? Now, all we're going to do is we're literally going to take this formula and we're going to plug in, okay? So, opposite B would be what? Negative 5 plus or minus the square root. So, look at the formula on the board. B squared, so B squared minus 4 times A times C all over 2 times A.
Wait, so
look at the formula, look at the formula.
No, where 3 comes from? I'll put it in A.
Mm-hmm.
You put a calculator like that?
Okay. No, we're going to take it the step by step like I showed you. So the first thing we're going to do is what's under the radical. Okay. So let's work on that radical first. That's the place everybody makes mistakes, is under that radical. The square root. So negative 5 plus or minus the square root. 5 squared is what? Take that hood off, Gavin. 25.
With 2x? Oh. Girl, all we did was bring it down.
Yeah, that's the B. Minus. What is 4 times 3 times negative 8? Use your calculator.
Is that negative 4?
Don't, no, just leave, what is it? Negative 96. And 2 times 3 is 6.
96.
I'm going to change it in just a minute, but I'm taking it step by step. If it's easier for you to do this, then do that. Okay? If you do same, change, if you do plus or negative instead of minus. All right, look. Use your calculator. What is 25 minus negative 96? We're still working on that radical. What's the square root of 121? 11. So I've got, and I'm going to come over here because I'm out of room, negative 5 plus or minus 11 over 6. All right. Now, I need you to think about this for just a minute. When we had a plus or a minus before when we were solving with square roots, what did we do? That's right. We split it up into 2, right? At this point, I'm going to split it up into 2. I'm going to say this is the same thing as negative 5 plus 11 over 6 or negative 5 minus 11 over 6. It's a fraction. Hit math, enter, enter. All right, top first, and then we'll divide.
You put
Negative 5 plus 11 is what? 6.
Hold up, wait. I did this
No, you did the other one first.
So what have you want?
Yep. What's negative 5 minus 11? Negative 16 over 6, and that reduces to negative 8 over 3. If you divide it on your calculator and then hit math, enter, enter, there are your two answers. All right, example number 2. What's the problem with the way it is? It's non-standard form and it doesn't equal 0. So I need to make it equal 0, so I need to move what? X. Now, remember what standard form looks like. Right? So I need to move the X, but when I move the X, it needs to be in the middle, not on the end, right? Do you see why? Standard form puts the X in the middle. It's the X squared, then the X, then just the constant. So you tell me, what does this equation look like? Yes. That's right. All right. What is A? What is B?
Look at you.
Negative 1.
-1. What is C?
-7.
You going to school, my class?
12.
That means I'm trying to get your attention. Be quiet. All right. X equals. All right. Opposite B. So B is already -1 here. So what should it be? +1 plus or minus the square root of. I'm going to put this one in parentheses when I square it. It's just the formula. B squared 4. That is correct. Yes. Is anybody confused about just plugging it in? Okay? All right. Okay, so under the radical. All right, what is -1 squared? +1, right? When you square a negative. Now, your calculator, if you just put on your calculator -1 squared, it's going to tell you it's -1, right? You have to put the -1 in parentheses when you square it so that it reads it correctly, okay? So -1 squared is +1.
That's not
Minus it does, but what your calculator picks up when you do this, you know how like if you have -x squared, your coefficient is -1, and really that's the same thing as -1 times x squared. What your calculator does, your calculator reads this as -1 times 1 squared instead of -1 squared.
So in the
So
calculator,
to
it's gonna
force
do
it,
plus.
you have to do the parentheses.
So you're going to put a second this, then you put another parenthesis middle of one. You write it?
Yeah.
I got 1 minus 56.
Negative, right. So it's 1 minus -56.
Why? Why is it negative?
All right, look.
But 4 times 2 times negative 7 equals 52.
So you actually put 4 times 2 times 7?
Yeah, because if you get that
4 times 2 times negative 7.
So it's not negative 4 right now?
Nah, that's
All right, so listen, you can't. Let me do that one. Let me do this one that way because that's the way y'all are wanting to do it. So you see. Yeah, if you make this, whenever you do it, see the problem is if you just do negative 4 but you don't change the subtraction sign in the middle, you're going to have the wrong sign. So if you're wanting to do that, here's what you have to do. You have to do same, change, change. And so now it's 1 plus, what is negative 4 times 2 times negative 7? 56. It's the same thing.
Okay.
It's the same thing. It's just, if you did it the other way, you would have the square root of 1 minus negative 56. And that would still give you the square root of 57 that we're going to give you. Yeah.
Okay, so when you say like, multiply negative 56,
You can. Just make sure if you put a plus between that you change that 4 to negative also. All right. Does 57 have a perfect square? No. Since it doesn't, I leave it as the square root of 57. Now, when I look at the top, and let's go ahead, let's split up our plus and minus, okay? We got 1 plus and 1 minus, right? So we'll do, you all right, Christian? 1 plus the square root of 57 over 4. Yes. And 1 minus the square root of 57 over 4. Now, since we can't reduce 57 anymore, we just leave it here. We're done. So I think I'm going to get you to practice some with quadratic formula, and then Monday we'll talk about some ways on how you know, like Christian was saying, can I just factor it? How we know when is the best method to use what when we're solving.
So you understand?
That's when you have to apply what you've learned.